Extraction Lab Part 2 by Christy Oblea. What kind of compounds are we trying to extract? The compounds in our unknown are non-soluble in water, soluble in ether. That means the compound is non-polar. Also, there are three different possibilities of compounds in our unknown. It could be basic, acidic, and or neutral. How are we going to get out our acidic, our basic, and our neutral compounds? By making the compound into a salt that would make it soluble in water. So to get the basic compound out, we must add acid to make the salt, and it will come out in the aqueous solution. So in this part, we'll be using hydrochloric acid to make our salt. To get out the acidic compound, we must add base to make the salt, and then that will come out into the aqueous solution. In this lab, we'll be using sodium hydroxide to make the salt. And to get out the neutral, since it will be the only compound left in the ether, we just need to evaporate the ether, and the neutral will be left behind. In this lab experiment, we are using unknown number 54, weighed out at 103.1 milligrams. This is the setup we will be using to extract the compounds. Right here is the tube that we'll be using to hold the ether with our unknown compounds in it. In this first step, we'll be extracting the basic compound from the ether. We will be adding the hydrochloric acid into the ether layer and mixing it with these pipettes while it's inside the tube. Once we are finished mixing, we let the two different layers settle so that we can extract the bottom layer, which will be the aqueous layer that will hold our basic compound in its salt form. In this image, you can see the different layers of the basic compound in the aqueous solution and the ether layer. Once it was extracted, we had our basic and the hydrochloric extract. We made the hydrochloric extract basic to the litmus paper, but there was no precipitate inside the aqueous solution. We added base to the aqueous solution so that we can have the salt go back into a basic compound so that it would separate out from the aqueous solution as a precipitate. And as no precipitate has formed, we have no basic compound in our unknown. In the next step, we are extracting the acidic compound from our ether layer. So we added sodium hydroxide into the ether and mixed it with pipettes. After letting it settle, we can see the two layers, the aqueous layer at the bottom holding our acidic compound as a salt. Then we separated our aqueous solution from the ether, our acidic compound and the sodium hydroxide extract. Then we made the solution acidic to the litmus paper by adding the acid back into the aqueous solution. We want to precipitate out our acidic compound, and we got precipitate. We continued to add acid until it was acidic to the litmus paper. And that's when we stopped adding acid and no more precipitate formed. So at the end of day 1, we were able to separate what could have been our basic compound, our acidic compound, and the neutral, which is still in the ether. With the acidic compound, we funneled it out to get only the crystals out of the aqueous layer. The extraction of the neutral happened on the second day of lab, it was still in the ether layer, what we did was we add sodium phosphate to absorb any water that was still left in the ether after mixing with several different aqueous solutions. And after evaporating the ether, we were left with our neutral compound. What we have left was two different compounds. We had our neutral, which were white crystals, and our acidic, which is also white crystals. We did not have any basic compound in our unknown solution. So how are we going to identify what our unknowns are? We're going to use melting point. We use melting point as a way to identify our unknowns using a list of possible unknowns. Here is our list of what our possible unknowns can be. This is the apparatus that we'll be using to test our melting points. In this column, we have our acidic component, and in this column we have our neutral, still in crystallized form. As we can see in the images, we can see that our acidic started to melt and completed melting by 103 degrees Celsius. And for our neutral, it started melting and completed melting around 111 degrees Celsius. Based on these results, we were able to ascertain that the acidic component was O2-oleic acid and our neutral component was fluorine. How we are able to decide this is that every compound has its own precise melting point. With pure O2-oleic acid, has a melting point of 104 and 105 degrees Celsius, but that is with pure O2-oleic acid. Since our extracted component has a possibility of being not pure, our melting point is going to be slightly lower than the 104 and 105 degrees Celsius. And as our melting point was 103, that was the closest possibility for our unknown acid. For fluorine, the melting point of pure fluorine is 114 degrees Celsius. Our neutral had a melting point of 111. As there were no other possible compounds around 111 degrees Celsius other than fluorine, that was our best possibility for our neutral component. In this lab, we started with 103.1 milligrams of our unknown. We got 45.6 milligrams of our O2-oleic acid, and we got 29.6 milligrams of our fluorine. The total amount of compound collected was 75.2 milligrams. We had a loss of 27.9 milligrams with a 72.9% yield. The reason for so much loss is that not all of the compound could be collected from our flasks and containers, and some loss occurred that way. There was no major errors in this lab, and we correctly identified our two unknowns in our unknown compound.